All right, well, hopefully you did well on that quiz. Students in here did a great job on that, so hopefully you did as well. Well, let's go and pick up in your notes where we left off yesterday, talking about the general form of a linear equation. Again, you've got your ax plus by is equal to c. Again, we said a, b, and c must be class integers, and there's something else that's special about the a. It must be positive. So a, b, and c are all going to be integers. A specifically also must be a positive. We're never going to lead with a negative. We're never going to have any fractions in the equation in the general form. Now, on the surface, this doesn't present any benefits as far as instantly seeing things like intercepts or slope or things like that. But I gave you ratios that would allow you to easily find the slope, the x-intercept, and the y-intercept. What was the formula to find the slope of a line if we were given this general form? Jamie?
M equals negative a over b.
Good, negative a over b. We make the ratio, we change its sign to negative if it's positive, positive if it's negative, and there's your slope right there in front of your face. The a, which represents our x-intercept, how did I find that, Quentin?
C over a.
C over a, of course, then is 0. And then the b or the y-intercept.
Zero, c over b.
There we go, you're tired, it's Friday. All right, so 0 c over b is how we would solve those. So as we look at page 223 now in your textbooks, as we look at page 223 in your textbooks, we can find the slope of the line from the general form very quickly and easily. We just make a ratio of the first two coefficients, a and b, and then we change the sign. So 1a, there on page 223, what is that slope, Quentin?
2.
Positive 2. 2 over negative 1 would be negative 2, but then change the sign positive 2. Jamie, what would be the slope on letter B?
Negative 1 over 5? Or 5 over 1?
Letter B. You're going down to letter C. Letter B.
A over 6?
The slope.
The slope. Okay, negative 6 over 10.
Negative 6 over 10, right? So once you got your brain wrapped around, right, we're just looking at these two numbers, 6 tenths, stick a negative in front, negative 6 tenths. 2 one-ths, well, negative, change the sign back again to a positive on that one. So 2 positive or negative 6 tenths, or reduced down negative 3/5. Now letter C, it's not set up for you, is it? Letter C, we need to put it into the general form. What does it look like in the general form, Quentin?
It's minus 3/5%.
All right, so now we make the ratio and we change this sign. Positive 1/2. Look at the next one, Jamie. Let's put that in slope into the general form, rather.
3x plus 2y equals 8.
All right, take this ratio, change this sign.
3 halves. Negative 3.
Negative 3/2. Look at the next one. 4y equals 7. I don't even see an x term, do I? Which means it's 0x plus 4y. So what's the slope?
0/4.
Negative 0/4. But that's really just 0. After all, we could get the y by itself. That means it's y equals, which means it's parallel to the x-axis, which means it's a horizontal line, which means 0 slope. But we can see the negative 0/4, or just 0, just like that. Look at the next one, Jamie. It says 2x equals 11. What's missing?
The y.
So we could write it as a,
Positive 0 y.
yeah, 2x plus 0y equals 11. Well, right there's our ratio for slope.
Negative 2 over 0.
Negative 2/0, but that is,
Negative 2.
ooh,
Yeah.
anything over 0 is undefined. There we go, undefined slope. Does that make sense? Questions on how to quickly see the slope. Do we want to practice a couple more, or do we feel like we've got it? We got it? Okay. All right. Look at number 2. It says, list which of the following lines are parallel and which are perpendicular. Well, here we go. More practice with slope anyway. Letter A, what's the slope, Jamie?
Positive 3/4.
Good. Make the ratio, change the sign. So positive 3/4. Now letter B is not set, it's not in general form technically. What is letter B in general form, Quentin?
6x minus 8y equals 1.
initially negative 6x plus 8y equals the 11, right? But since we're not allowed to lead with a negative, so
6x minus 8y.
was that what you were saying a moment ago? I just want to make sure the camera I could specify for the camera what we're doing here. So what is the slope then?
3/4.
Positive 6/8 or positive 3/4. Look at letter C. Here it's set up for us. Jamie, what's the slope?
Negative 8/6.
Negative 8/6 or reduced down.
4/3.
Negative 4/3. Number 9's not set up for us yet. We need to get it in the correct order here, Quentin, on D.
9x plus 4y equals 10.
And so what's the slope?
Negative 3/4.
Negative 9/12 or negative 3/4. So which of those lines are parallel to each other?
C and D. No. Oh, A and
Did you write down the slopes? that would help, right? Sorry, I guess I should have mentioned write down the slopes as we're doing this. So we said A was what slope, class?
3/4.
3/4. Letter B was,
Positive 4/3.
ooh, careful. Look at it this way. Letter B was
Positive 3/4.
positive 3/4. Letter C was negative 4/3. And letter D was negative 3/4. Okay, which lines are parallel? A and B are the only ones that are parallel, right? Which ones are perpendicular? C and C and A or C and B, right? D is just kind of, no, it's not anything, is it? It's just its own line. It intersects the others, but that's not parallel or perpendicular. Does that make sense? So let's think about this. Parallel or perpendicular lines. Well, remember, parallel means, and since the AB thing is really what defines the slope, if they have the same A and the same B, or could reduce to it, they're going to have the same slope. They're going to be parallel, right? So in the general form, parallel lines would be such: AX plus BY equals C, and AX plus BY equals, for instance, D. If they have the exact same starting or equivalent starting points, reducible to the same, they'd have to be parallel. Does that make sense? Perpendicular lines, on the other hand, have, class, negative reciprocal slopes, which means this sign has to be positive, right? This sign could be positive or negative. So if we change this sign, that would give me a negative slope. And if I flip the numbers, that would make a reciprocal. So a perpendicular line would be BX minus AY equals, for instance, D. Does that make sense? So flipping the numbers and changing the middle sign will make a perpendicular line in that general form. So let's suppose then, let's build on this thought. Let's work a problem similar to one maybe we've done before. We have a line through the point 1, negative 3 that is parallel to 5x minus 6y equals negative 14. Well, any and all lines parallel to this one are going to start out the same way. Every single line parallel to this one has to start how, class? 5x minus 6y equals something, right? When we see 5x minus 6y equals, we know whatever comes in, we know all these lines are going to be parallel, right? Infinite number of lines could start 5x minus 6y equals. Now, we want the line that's going to go through the point 1, 3. Well, what C value or D value or what constant value would make sure the line goes through this point? Well, if we plug in a 1 and we plug in a negative 3, then we'll definitely get a point that satisfies. We'll get the exact C value for the parallel that goes through that point. We're going to get 23. That's the parallel through that point. Rather than, okay, let's get it in slope-intercept form, let's find the slope, let's use the slope formula. So much faster now, right? With some of these events. What if it had said perpendicular? Well, there's an infinite number of perpendiculars to this line, but every perpendicular is going to start how? 6x plus 5y equals something. And there's an infinite number of perpendiculars, but only one can come from or through this point. Which perpendicular goes through that point?
Oh, negative 9.
Negative 9. 6 times 1 is 6, 5 times negative 3 is negative 15, negative 15 and 6 gives negative 9. That's the perpendicular to that line that goes through that point. Does that make sense? Again, so much faster than what we would have been able to do before, now that we see how the general form works. So in a way, once you learn some facts about the general form, it's like, wow, this actually is easier than all the other ones, right? I think the other ones were helpful in learning some key things, but man, the general form really does give us a lot of ability to work efficiently. Look at the top of page 223. They have a very similar problem. Read the example for us, if you would, Quentin. Page 223 at the top of the page, example 4.
Find the general form equation of a line perpendicular to 2x plus 5y equals 8, and a line parallel to 2x plus 5y equals 8. Each line to be found affects the particular.
All right, so we start with a parallel, and the equation you said was 2x plus 5y equals 8? Is that right? Yes. So that means every, it starts with perpendicular, excuse me. Starts with perpendicular. So every line perpendicular to 2x plus 5y equals 8 has to start how? 5x minus 2y equals something, right? And so that's what they did. For the perpendicular, you see they started with 5x minus 2y equals, and they just wrote a c instead of a blank. Then they substituted in the point through which that perpendicular passes, the point 2, 3. They found that c was 4. Do you see how they got the perpendicular 5x minus 2y equals 4? For the parallel, well, if it's parallel to 2x plus 5y equals 8, all parallels are going to start how? The same way. So 2x plus 5y equals something, right? 2x plus 5y equals blank. Again, I would leave a blank instead of the c. Then again, they plug in the 2, 3, they get 19. So the parallel, 2x plus 5y equals 19. Does that make sense? All right. Turn over to page 224. On page 224, I want you to do number 3, ace, and number 4, ace. Number 3, ACE, and number 4, ACE. Practicing with parallels and perpendiculars. Take a look at those in just a moment. Give you a couple moments to work. take a look at these and see how we did. Number 3, letter A, what was the parallel line through the point 5, -6? Jamie?
2x plus y equals 4.
Good. Letter C, Quentin, what did you have for the parallel line?
X plus 3y equals -13.
Good. X plus 3y equals -13. And what about letter E, Jamie?
X plus 0y equals 5.
Good. Or just x equals 5 would work as well. How about number 4? Letter A, finding the perpendicular this time. What was your perpendicular through the point 5, -6? Quentin?
X minus 2y equals 17.
Good. X minus 2y equals 17. Letter C, Jamie?
3x minus y equals 21.
3x minus y equals 21 is correct. And letter E, this is tricky. What was the perpendicular, Quentin?
2x minus 0y equals 10.
Which could reduce down to get x equals 5. There we go. All right, questions on those. Do we need to see any of them worked? Feel like we've got them? All right, if you're watching on YouTube, you need help, let me know. But they're good to go in here. Let's revisit now. Back on page 221. I showed this yesterday in the lesson, but I want to kind of hit it again. Look at example 2. Read that for us if you would, Jamie.
Find the general form equation of a straight line with slope 5, 6 passing through the point 2, 4.
All right. So remember what we said is if the slope is 5, 6, then there's my A and there's my negative B. So I know if the slope is 5, 6, it's 5x minus 6y equals. Does that make sense? And then they said if it passes through the point 2, 4, remember we just plug in the 2 and the 4, and that's where we got our answer, 5x minus 6y equals -14. So there at your seats. Let's suppose I know that the slope of a line is 3/4, and what would be the start of every equation for which the slope is 3/4? Quentin? In the general form, every equation with a slope of 3/4 starts how?
Oh, x over.
Jamie, help us.
3x plus 4y.
Well, but remember, slope is negative everybody, so we're going to change that sign. -4y equals something, right? What if the slope, Quentin, is a -2/5? Every equation with this slope is going to start how?
2x plus
2x plus 5y equals something in plus because it said minus. We always change that sign. What if the slope was a -7, Jamie? Every equation with a slope of -7 is going to start how?
7x minus 1.
Change the sign.
Positive 1y.
Good. 7x positive 1y equals. What about a slope of 3? Quentin, every line with a slope of 3 is going to start how?
3x minus 1y.
Good. 3x minus 1y is equal to something. Does that make sense? And if you can get a hang of that, it's going to really, really help us as we move forward. So seeing slope in the equation or seeing the equation when we know the slope. Does that make sense? Let's use that now as we turn over to page 224. Read number 5. What are we doing here in problem number 5? Quentin?
Find the equation of the line connecting points of the intersection.
And they give us a couple of systems. All right, so here's where we have some real fun. All right, so the first system has x plus y equals 4. What shape, class? Straight line. And x equals 6. What shape? Straight line, specifically a vertical line, parallel to the y-axis, correct? These two lines, a vertical line and a non-vertical line, have to intersect once. We're going to get a point of intersection from that. Then they also give us 3x minus y equals 12. Of course, class, that is a straight line. And y equals -6. That is also a straight line, specifically a horizontal line parallel to the x-axis. These two lines have to intersect at one point. Through these 2 points of intersection, we could draw a line. The question is, what's the equation of that line? Does that make sense? So these aren't hard systems at all. Take just a moment to get both points of intersection. What's the point of intersection for the first system, class?
6, -2.
6, -2. Just plug in the 6, you get the -2, boom, we're done. What's the point of intersection for the second equation going to be, class?
2, -6.
2, -6. All right. Through 2 points, if I want to know the line, the first thing I must know is the slope. So what is the slope of the line now going to be?
1.
1. Every single equation that has a slope of 1 must start how? Class? X minus y equals something, right? Positive 1 over 1 means 1x minus 1y equals something. Now, to figure out the something, I can take either this point through which the line goes or this point. I'm going to take the 2, -6. What's the end of the equation? 8. There we go. That's the line through the points of intersection of these two systems. Does that make sense? Let's do part B. Part B. We've got a cubic. Remember, that's that kind of curve. Okay? So we've got a y equals x cubed minus 9x and x equals 1. That's a straight line. Now, technically a line could cut through at 3 points, but they're already telling us it's only going to cross once. There's going to be 1 point of intersection here, and then y equals x cubed minus 9x, and the line x equals 3. And again, they're telling us there's only going to be 1 point of intersection. The equation of the line that joins those 2 points of intersection. At your seats, do the whole process this time. All right, Quentin, what's your first point?
1, -8.
And Jamie, your second point?
3, 0.
3, 0. To know the equation of the line, we must know the slope. And what is the slope, Quentin?
4.
Yes, 4. Or we could say positive 4 over 1. If I write it like this, it makes it easier to see how my equation starts, Jamie.
4x minus y.
Equals something, and I'm just going to take the 3 and the 0, and that helps me finish my equation to be 4x minus y equals 12. Did you have this equation for your answer?
I got stuck. I can't remember about using the 12, using points to find the 12. But
I got you. Does that make sense? Now you take either of the points, it gets you the same thing. All right, let's drop down to number 6. Go ahead and read number 6, if you would. Jamie.
A perpendicular passes through 2, 4, and meets the line at 3, -1. Find the equation of the
Perpendicular, and then the line. This is kind of worded weird. Normally we already have a line. Here they're telling me there is some line we'll call line, and there is some perpendicular which we will call perpendicular. The perpendicular passes through, class, a point called 2, 4, and it meets the line at what's called the foot of the perpendicular, remember from geometry, and the foot of the perpendicular is 3, -1. Which of these two lines do I know enough information to find? The line or the perpendicular? The perpendicular, I know 2 points. The line, I only know 1. So I actually don't know enough for the line yet. But in order to find the equation of the perpendicular, class, I need to know the slope. What is the slope of this line, Jamie? Of the perpendicular, excuse me. What's the slope of the perpendicular?
-5.
-5. Oh, or -5/1. Then what's the slope of the line then, Quentin? 1/5. If the perpendicular has a slope of -5/1, I know the perpendicular equation starts how, Jamie?
5x plus y.
There we go. And therefore, even if I didn't look at this, I know that the line's equation, Quentin, is going to start x minus 5y equals something. Make sense? Now, how do I figure out the something at the end of the perpendicular's equation, class? Use either 2, 4, or 3, -1. Which one should we try? 2, 4 gives us 14. How do I figure out what finishes the equation for my line? I have to use 3, -1, right? 2, 4 isn't part of the line. It's the foot of the perpendicular, so it's on the line. Plug in the 3, -1, class, we get 8. And there's the equation of the perpendicular and of the line. Make sense? You do the same thing here, and a picture may help you like it did here on number 7. You at your seats do number 7. Before you can find an equation, class, you gotta have the slope. And what is the slope of the perpendicular going to be? -5/4, which means the equation of the perpendicular, class, must start
5x plus 4y.
5x plus 4y equals something. Now to finish the equation, I'm going to have to plug in one of the points, preferably the 0, 0, and I get 0. If that's the equation of the perpendicular, Quentin, how does the equation of my line start? And to figure out what the something is here, Jamie,
Yeah, to plug in the other point.
plug in the 4, -5. I could have plugged this in both times. I have to plug this in the second time, and what do I end up with, Jamie? Kind of a bigger number here.
41.
41. Is that what you had as well? Any questions on parallel and perpendicular within the general form? All right, your homework for this evening is to do page 224. Page 224, number 3, BDF, number 3, BDF, and number 4, BDF. Page 224, number 3, BDF, and number 4, BDF. And we'll continue working with the general form and see some more things we can use it to get in our next lesson. Have a wonderful rest of your day, and when the bell rings, you'll be dismissed.